Remember that doing hypothesis tests, it's really just about comparing two or more numbers to each other. So, for example, you have your hypothesis that your slope is here, that around 0. So that is your null hypothesis, which means that the true beta is equal to 0. Your alternative hypothesis is everything else. So, for example, your alternative hypothesis is that beta 1 is different from 0, right? What if you get a beta hat over here at for example 2, then you just compare the like -1 standard error to either side, a two-sided test, standard error, right? And you just compare how many standard errors this hypothesized value is from your observed value, right? And if it's too far away in standard error terms, then you say that this is not logical. So I reject that the true beta can be 0, right? So, but when testing hypotheses about the coefficients in a regression model with more than one right-hand side variable, there are actually 3 kinds of tests that we might encounter. Okay, so that would be the test of a single coefficient, a joint test of coefficients, and a linear restriction test. Okay, so and the 2 main tools we are using is the t statistic and the f statistic, right? So what do we make of this is that the type of test can either be a single restriction, right, involving one parameter, joint restrictions involving multiple parameters, or a linear combination of coefficients. The 2 most common types of tests, they are single and joint. And for a single test, for example, the hypothesized value is 4, and the alternative hypothesis is that the slope here is different from 4. You would use the t-stat to compare the beta 1 hat to the null hypothesis. Sorry. Whereas with the joint test, you would most oftenly look at the slopes, more than one slope, often all these slopes in the model, and the hypothesized value would be 0 on all of them. So your null hypothesis is that they are jointly equal to 0, and to compare or to assess the validity of this null hypothesis, or the probability of this null hypothesis, you use the F statistic. So the t-stat and the f-stat, they are often included in the regression output from your statistical software. The t-stat is included for every single coefficient, the slopes and the intercept. The f-stat is included as a overall measure of fit, and whereas the linear combination of coefficient tests are quite uncommon, and they are not included in the standard output from regressions. So as we can see from the table, we use the t-stat when we have one equation in our null hypothesis, and we use the f-stat when there is more than one equation in our null hypothesis. In our next video, we are going to look more into the details.